Hello friends, welcome to full course on signals and systems. In the previous lectures we have discussed standard signals such as step signal and rectangular signal. In this lecture I am going to discuss about a ramp signal. Let's move on to the lecture. Ramp signal. A ramp signal can be defined as K into R of t is equal to Kt for t greater than 0 and 0 for t less than 0. That is, for positive time it is Kt and for negative time it is 0. Here the Kt is in the form of the straight line equation y equal to mx plus c. So let's check the graph of ramp signal. In the x-axis it is t, and the y-axis it is k into r of t. For negative time it is 0, that is negative time means t less than 0, it is this part, and t is equal to 0 is the origin, and this part is t greater than 0. So for negative time the value is 0 as shown in the figure, and for the positive time it follows the equation of a straight line, and the slope of the straight line is k. In the equation of straight line, the coefficient of x determine the slope. So in this case the coefficient of t determine the slope, which is equal to k. So what is the slope? The slope means dy by dx, that is change in y corresponding to change in x. Here dy by dx equal to k means for every 1 unit change in x axis, the change in y axis will be equal to k. This is the meaning of slope. So while drawing the figure or the graph of ramp signal for t greater than 0, it follows a straight line equation with slope equal to k, which means that for every 1 unit change in x axis, the change in y axis is k unit, which is the coefficient of t here. So let's check what will happen if k is equal to 1. That is, if k is equal to 1, the ramp signal is called as unit ramp signal. It is same as the case of unit step signal. Here the unit ramp signal can be defined as r of t equal to t for t greater than 0 and 0 for t less than 0. That means this is the portion where t greater than 0, and this is the portion where t is less than 0, and this is the origin, t is equal to 0. So for negative time r of t is equal to 0, and for positive time it is following a straight line whose slope is equal to 1, which means that for every 1 unit change in x axis, the corresponding change in y axis will be equal to 1. This is the unit ramp signal, which means here the dy by dx is equal to 1. Let's compare the unit step signal with unit ramp signal. We know that the unit step signal can be defined as u of t is equal to 1 for t greater than 0 and 0 for t less than 0. We also know as it is not defined at t equal to 0. That is, the unit step signal is discontinuous at t equal to 0. And in the case of unit ramp signal, this is a continuous signal. In both cases, that is in case of unit step signal and unit ramp signal, we know that both signals are continuous time signals. But in the case of unit step signal, there is one discontinuity at t equal to 0. In case of unit ramp signal, at t equal to 0, the signal is defined. The value is 0 for t is equal to 0. So there is no discontinuity in a ramp signal, but in case of unit step signal, there is one discontinuity at t equal to 0. So let's see another expression for unit ramp signal. The ramp function can be defined as r of t is equal to t into u of t, where for positive time it is t and for negative time it is 0. So let's check why this is correct. That is, ramp signal can be defined from a unit step signal which is multiplied by a function t. So let's take t and u of t as separate signal, t and u of t. So by the equation it is saying that by multiplying t with u of t, we will get the ramp signal r of t. Let's check it. So let's draw the graph of t. That is, t means it is a straight line with a slope of 1. That is, it is a straight line passing through the origin. And u of t, as we all know, u of t is equal to 0 for t less than 0 and is equal to 1 for t greater than 0. So the equation is like this. By the equation, it is clear that the t into u of t is equal to r of t. So let's multiply these values. That is, here, that is for t less than 0, the u of t is equal to 0. So here t into u of t will be 0 for t less than 0. And for t greater than 0, it is equal to 1, and 1 multiplied with t, it will be equal to t. So this is a ramp signal. For t greater than 0, the value is t, and for t less than 0, the value is 0. So let's do the same thing by using the expression. So take the equation of unit step function, that is u of t is equal to 1 for t greater than 0 and 0 for t less than 0, and multiply t with u of t. So here the 1 get multiplied with t and 0 get multiplied with t. So the equation becomes t for t greater than 0 and 0 for t less than 0. So this is similar to the equation or definition of r of t, which is equal to t for t greater than 0 and 0 for t less than 0. So there are two types of expressions for ramp signal, that is, r of t can be defined as t into u of t. So let's do some shifting operation in ramp signal. We know that, or we have studied that, x of t minus 2 is the right hand side shifted version of x of t by 2 units, as x of t minus a is the right hand side shifted version of x of t by a unit. So here r of t minus 2 is the right hand side shifted version of r of t by 2 units. So let's check it by using the expression, that is the basic expression or definition, that is r of t equal to t for t greater than 0 and 0 for t less than 0. Here put t equal to t minus 2. So r of t minus 2 is t minus 2 for t greater than 2 and 0 for t less than 2. That is, we can draw the equation like, that is, r of t can be drawn as 0 for t less than 0 and t for t greater than 0, and r of t minus 2 is the right hand side shifted version of r of t by 2 units. So here it is 0 and here it will be 2. So the graph will look like this. It is the right hand side shifted version of r of t by 2u. Let's do one example. That is 3 into r of t plus 5. So 3 into r of t plus 5 is the left hand side shifted version of 3 into r of t by 5 units. Why it is left hand side shifted version? Because it is t plus 5. Previously we have taken the example as t minus 2. So the minus sign indicate the right hand side shifted version and plus sign indicate the left hand side shifted version. So let's start from basic equation, that is r of t equal to t for t greater than 0 and 0 for t less than 0. And 3 into r of t plus 2 is, here it is t plus 5. It is wrongly written as 2, it is t plus 5. That is, putting t equal to t plus 5, we get the equation that t plus 5 equal to t plus 5 for t greater than minus 5 and 0 for t less than minus 5. So let's draw the graph. That is, here we can draw 3 into r of t first, and we can shift the 3 into r of t or 3r of t by 5 units to the left hand side for getting 3r of t plus 5. So 3r of t, here 3r of t, the 3 indicate the slope. That is, every 1 unit change in x-axis, there will be corresponding 3 unit change in y-axis. So the graph will look like this. That is, here the rest of all things will be same, but slope will be equal to 3. That is 0 for negative time and 1 for positive time, or t for positive time. So for left hand side shifting of this 3r of t by 5 units means here the value is minus 5. So it will be left hand side shifted version of 3r of t, which will look like this. Here the slope will be the same, that is 3. That means for each 1 unit change in x-axis, the corresponding change in y-axis will be 3. So we can find the point which intersect on the y-axis, in which value the 3r of t plus 5 will intersect on y-axis. The value will be equal to the change in x-axis multiplied with the slope, that is minus 5, or we can take the value, that is plus 5 into 3, which is equal to 15. So this value will be 15. That is, the value in which the 3r of t plus 5 intersect on y-axis is 15. So for every question, start from the basic equation and then proceed. It will be easier for you to solve any difficult question. So let's wind up this session. If you like the video, please like and subscribe our channel and share this video with your friends and comment your suggestions in the comment box. Thank you. Bye-bye.